Dear students, welcome to Mathematics Online classes. We are solving exercise 10.2. In that, question number 6. Question number 6 is given as find the sum of the vectors vector A, vector B and vector C. There are 3 vectors given to us. We need to find a sum of all these. Sum of vectors is equal to vector A plus vector B plus vector C. Okay. Vector A is I minus 2j plus k plus of vector B is minus 2i plus 4j plus 5k plus vector C is I minus 6j minus 7k. This is equal to, see, how will you add? We will add up corresponding components. I minus 2 means minus 1 plus 1 0. It is 0 into I cap. Minus 2 plus 4 plus 2 plus 2 and minus 6 is minus 4j. I 6k and that one, that will be minus k. So, sum of vectors is minus 4j minus k. That is about question number 6. Now, we will take the next question, that is question number 7. Question number 7 is find the unit vector in the direction of the vector. Find the unit vector in the direction of the vector. Unit vector in the direction of the vector A is equal to, vector A is equal to I plus j plus 2k. This is about question number 7. Find the unit vector in the direction of vector A. See, we know that unit vector in the direction of the given vector is equal to vector A divided by magnitude of the vector. So, let us find out magnitude of the vector first. Given vector is vector A is equal to I plus j plus 2k and magnitude of this vector is square root of 1 square plus 1 square plus 2 square. This is square root of 1 plus 1 plus 4. We have as square root of 6. This is magnitude of the given vector. Now, we know that unit vector in the direction of vector A is A cap. A cap is equal to vector A divided by magnitude of vector A. This is a standard formula, we know it. Now, vector A you write, that is I plus j plus 2k divided by magnitude of vector A is square root of 6. This square root of 6 will get divided to all the terms. Here we have 1 by root 6 into I cap plus 1 by root 6 into j cap plus 2 by root 6 into k cap. What is this? This is unit vector in the direction of the given vector. Let us take the next question, that is question number 8. Question number 8 is find the unit vector in the direction of unit vector in the direction of vector PQ in the direction of vector PQ, where P and Q are points, where P and Q are points 1, 2, 3, 1, 2, 3 and 4, 5, 6 respectively. See, find the unit vector in the direction of vector PQ. Here P and Q are points given to us. Points are given in the sense easily we can write the position vectors. P coordinates are 1, 2, 3. So, position vector of point P is 1i plus 2j plus 3k, and 4, 5, 6 are the coordinates of point Q. We can write the position vector of point Q also, that is vector OQ is equal to 4i plus 5j plus 6k. Now, here you see, find the unit vector in the direction of vector PQ. First of all, let us find out vector PQ. Vector PQ is equal to, this is a vector joining two points P and Q, where P is initial point, Q is a terminal point. Now, vector joining two points, vector PQ is equal to position vector of second point minus position vector of first point. 4i plus 5j plus 6k minus of position vector of point P, that is I plus 2j plus 3k. Now, corresponding components is subtraction, 4i minus I, 3i, 5j minus 2j, 3j, 6k minus 3k plus 3k. What is this? This is vector PQ. They asked you to find out a unit vector in the direction of this vector PQ. So, unit vector in the direction of vector PQ is equal to vector PQ divided by magnitude of vector PQ. Do you know the magnitude of vector PQ? We don't know. Let me find out here separately. Magnitude of vector PQ is equal to, this is square root of 3 square plus 3 square plus 3 square is square root of 9 plus 9 plus 9. 3 into 9 I can write. 9 plus 9 plus 9. 3 into 9 is 3 into root 3. What is this? This is vector PQ is equal to. Now, let us substitute vector PQ and its magnitude here. We will get the unit vector. This is 3i plus 3j plus 3k divided by 3 into root 3. This 3 into root 3 will get divided to all the terms. So, we have the unit vector as 3 by 3 root 3 into I cap plus 3 by 3 root 3 into j cap plus 3 by 3 root 3 into k cap. 3 get cancels out. We have 1 by root 3 into I cap, 1 by root 3 into j cap, 1 by root 3 into k cap. This is what? This is unit vector in the direction of vector PQ. Okay. This is about question number 8. We will take the next question, that is question number 9. For the given vectors, vector A is equal to 2i minus j plus 2k, and vector B is equal to minus I plus j minus k. Find the unit vector in the direction of in the direction of the vector A plus B, direction of the vector A plus B. We need to find out unit vector in the direction of vector A plus vector B. So, let us find out vector A plus B first. Vector A and vector B, they have given you separately. First of all, finding the sum of these two. Vector A plus vector B is equal to, vector A is given as 2i minus j plus 2k, plus of vector B is minus I plus j minus k. Okay. Now, corresponding components we will add up. 2i minus I minus j, and it is plus j, it is 0j, 2k minus k, it is plus k. We have here I plus k. Here you see j component is 0, we will leave that. Simply we will write I plus k here. What is this? I plus k is vector A plus vector B. They ask you to find out a unit vector in the direction of this. So, let us find out magnitude of this. Magnitude of vector A plus vector B is equal to square root of 1 square plus 1 square, nothing but square root of 1 plus 2, that is 1 plus 1, square root of 2. Magnitude of vector A plus vector B is square root of 2. Now, unit vector in the direction of vector A plus B is equal to vector divided by its magnitude. So, here vector itself is A plus B divided by its magnitude, vector A plus vector B, its magnitude we are writing. A plus B vector is I plus k divided by, this is square root of 2. We have 1 by root 2 into I cap plus 1 by root 2 into k cap. What is this? This is unit vector in the direction of vector A plus vector B. Okay. This is about question number 9. Now, question number 10. Question number 10 is find a vector in the direction of in the direction of vector find a vector in the direction of the vector 5i minus j plus 2k, 5i minus j plus 2k, which has magnitude 8 units, Okay. Now, see, find a vector in the direction of vector. We need to find out one vector here. Direction is 5i minus j plus 2k. Which direction it is moving, in that direction only that resulting vector has to be, which has the magnitude of new vector which you are going to find out, that should have the magnitude of 8 units. Like that we need to find out a vector. That is our question here. See what to do. If you take this vector, it will be having some magnitude, it will be having some length. So, what we do, we need to find out a new vector in this direction, you know. So what you do, we will find out a unit vector in the direction of the given vector. Let us find out the unit vector in the direction of given vector that will be having the magnitude of 1 unit. For that vector, we will multiply with a scalar quantity 8. If you multiply the unit vector with 8, that resulting vector will be having the magnitude of 8 units. Simple question it is. Okay. Let us take A is equal to the given vector, that is 5y minus j plus 2k. I will find out unit vector in the direction of this. For that, we need a magnitude. Magnitude of the vector is square root of 5 square plus minus 1 square plus 2 square. This is square root of 25 plus 1 plus 4. How much is this? This is square root of 30. Now, unit vector I will find out first of all. Unit vector in the direction of vector A is A cap is equal to vector A divided by magnitude of vector A. A cap is equal to vector A is what? Vector A is 5y minus j plus 2k divided by magnitude of vector A is square root of 30. This square root of 30 will get divided to all the terms. 5 by square root of 30 into I cap minus 1 by square root of 30 into j cap plus 2 by square root of 30 into k cap. What is this? This is unit vector in the direction of the given vector. We need to find out in this direction itself, we need to find out a vector having 8 units of magnitude. Now, a vector having magnitude 8 units in the direction of A cap is equal to 8 into A cap. That's all. 8 into A cap. 8 into, what is this A cap? A cap is 5 by square root of 30 into I cap minus 1 by square root of 30 into j cap plus 2 by square root of 30 into k cap. This 8 will get multiplied to all the terms. 8 into 5 is 40. 40 by root 30 into I cap minus 8 by root 30 into j cap plus 8 to 16 by root 30 into k cap. What is this? This is a vector having 8 units of magnitude and it is in the direction of 5y minus j plus 2k. Question number 10 it is. Now, next question, question number 11. Show that the vectors 2i minus 3j plus 4k, 2i minus 3j plus 4k and minus 4i plus 6j minus 8k are collinear. To show a given vector is collinear or not, we have two ways. One way is one vector is equal to some lambda times another one vector, that is vector B is equal to lambda times vector A. If it is possible to express like this, then A and B are collinear vectors. That is one way. Suppose the vectors are there in the component form, then if the corresponding components ratios are proportional, then the given vectors are collinear. That's all it is. Simple one. Now let me go with this method only. 2i, I will take this as vector A. Let A is equal to 2i minus 3j plus 4k, and vector B is equal to that another one vector minus 4i plus 6j minus 8k. Now I will consider this. Let us consider vector B is equal to minus 4i plus 6j minus 8k. See, I want to write this vector as vector B is equal to some lambda times vector A I want to write. See, vector A, here 2i is there, here what is there, minus 4i is there. So, let us take minus 2 common from all the components. Minus 2 I am taking common. Minus 2 is taken out, this will be 2i. Is it correct? You can check it. Minus 2 into 2 minus 4. Yes, it is correct. Minus 2 is taken outside, this will be minus 3j. Minus 2 is taken outside, this will be plus 4k. Is it same as the vector A or not? This is equal to minus 2 times vector A. Vector B is equal to minus 2 times vector A. Yes, these two vectors are collinear, where lambda, what is lambda? Lambda can be any real number. Here lambda value is minus 2. That's all. Yes. Therefore, B is equal to lambda A with lambda is equal to minus 2. Therefore, the given vectors are collinear. Therefore, the given vectors are collinear. This is question number 11. Now, we will take the next question, question number 12. Find the direction cosines of the vector. Find the direction cosines of the vector I plus 2j plus 3k. Very simple it is. Direction ratios are what? Direction ratios are nothing but a scalar components. So, here scalar components are 1, 2, 3. Direction ratios are 1, 2, 3. What about the direction cosines? Direction cosines, if you divide the direction ratios by its magnitude, those will be direction cosines. Let vector A is equal to, otherwise let us take vector R is equal to I plus 2j plus 3k. A, B, C are what? A equal to 1, B is equal to 2, C is equal to 3. These are the direction ratios. Now, direction cosines are L is equal to A by square root of R, M is equal to B by square root of R, it's not square root, magnitude of vector R, N is equal to C by magnitude of vector R. L is equal to A is 1 divided by magnitude of vector R. Let us find out magnitude of vector R. This is equal to square root of 1 square plus 2 square plus 3 square. How much is this? Square root of 14. 9 plus 1 10, 10 plus 4 14. So, L is equal to 1 by square root of 14. M is equal to, B value is what? B value is 2. 2 by square root of 14. N value is what? 3 by square root of 14. What are the direction cosines then? Direction cosines are 1 by square root of 14, comma 2 by square root of 14, comma 3 by square root of 14. This is question number 12. Now, question number 13. Find the direction cosines of the vector. Find the direction cosines of the vector joining the points. A of 1, 2, minus 3 and B of minus 1, minus 2, 1 directed from A to B. This is the question. Simple question it is. See, find the direction cosines of the vector. Right now I did how to find out direction cosines of a vector. Their vector was directly given to us. Here vector is not given directly, but what is given, points are given to us, so that we can find out the position vectors. Using the position vectors we can find out the vector directed from A to B, means vector AB we need to find out. Vector AB is equal to vector OB minus position vector OA. Like that you find out the vector AB, then you find out a direction cosines. I hope you will do this question. I am leaving it to you only. Now let us take the next question, that is question number 14. Question number 14 is, show that the vector I plus j plus k is equally inclined to axis, the axis, easily inclined to the axis OX, OY and OZ. Means our question is to show that the vector, what is this, I plus j plus k is equally inclined to the axis, x axis, y axis and z axis. Equally inclined means I have to show that angle made by the vector with x axis is same as angle made by the vector with y axis, and also that is same as angle made by the vector with the z axis, equally inclined, that is. So, angle made by the vector with the axis, what is that? I hope you know the concept of direction cosines. Direction cosines, cos of angle made by the vector is direction cosine. What is that? Cos alpha, cos beta and cos gamma. Alpha is the angle made by the vector with x axis, beta is the angle made by the vector with y axis, and gamma is the angle made by the vector with the z axis. Here let us find out alpha, beta and gamma, so that we can write the angle made by the vectors. Now cos alpha, cos beta, cos gamma are nothing but direction cosines. Let us find all those. Let vector r is equal to I plus j plus k. To find out direction cosines, we need the magnitude. Let us write magnitude also. Magnitude of vector r is equal to, this is square root of 1 square plus 1 square plus 1 square. This is square root of 1 plus 1 plus 1. Magnitude of vector r is equal to square root of 3. Fine. Now direction cosines we will find out. Direction cosines we can write it as LMN. LMN are nothing but cos alpha, cos beta and cos gamma. Direction cosines, cos alpha is equal to, L is equal to here A by magnitude of vector r. A means I component, B means J component, next C means K component, and cos beta is equal to B by magnitude of vector R. Then cos gamma is equal to C by magnitude of vector R. Cos alpha is equal to, what is A? I component is 1 by square root of 3. Next, cos beta is equal to 1 by square root of 3. Then cos gamma is equal to 1 by square root of 3. We need to find out alpha, beta and gamma, Here alpha is equal to cos inverse of 1 by root 3. Beta is equal to cos inverse of 1 by root 3. Then gamma is also cos inverse of 1 by root 3. All are same, right? Alpha is equal to beta is equal to gamma equal to. That means angle made by the vector with axis, x axis, y axis and z axis is same. That means the vector is equally inclined to the axis. Alpha is equal to beta is equal to gamma is equal to cos inverse of 1 by root 3. Therefore, the vector I plus j plus k is equally inclined to the axis, that is x axis, y axis and z axis. Okay, now we will stop it here. In the next class we will take remaining problems. Thank you.